Alright, so here we are again. Take a cylinder. Size the cylinder up. Now, when I'm designing the cylinder, I'm thinking about the rotation limit on things. So I want to make this as thin as possible, but I don't want it to be flawed in design. Sometimes you'll make something really small, or yeah, it's really small, and it seems like a good idea because it fits good here, but when you go to actually move it, it's not a good idea because you broke the sturdiness value of it. So I'm just getting a general idea how, if this was in the arm, would it fit in the center? Would it have any thin walls? So let's go like this: object, apply rotation and scale. That way when I rotate it, I can always go back. Good. I think it'll fit down in that arm pretty nicely. Again, if you want to see it, switch over to perspective, and you can make some adjustments to see if it'll fit down in that arm. And that's at a value of 10. Oops. So I'm going to just even that out to 10, because I know 10's good. Okay, now I can rotate that back to 0. Good. And I'm just getting a camera that works. Front looks good. So what I'm going to do now is attach this to the ball. And for right now, I'll just join the two together. That way I can always separate them. I'll make a duplicate of this one, just in case I need it again. And come to think about it, I'll make a duplicate of this one because it's about the same size, and I'll need to make a bigger one later. So object join, just for right now. I'm not going to Boolean it. I need its pivot point to be right here, right on that area. So mesh snap, cursor to selected. Object transform origin to 3D cursor. And then I can rotate this. Okay, so I'm going to generally place this where I can get away with it. I see that the peg is a little offset from the sphere itself. That's okay though. Actually, because the limit of rotation here against we can't move our arm back very far. Uh, in fact, that's a whole different joint altogether. You know what I mean? Like, do it. I mean, you can move your arm a little bit, but that's about it. But the rest is called a shoulder joint, which is a different joint. Here, I would say that's okay. Okay, we'll get back into this mode. So this is taking a little bit more time because I have to think a little bit more than I had to in the last videos. So there I got nice space, nice space, nice space. I see a nice space there. I don't see it too close to here. I think we're good to go. So now I have the peg. So now I have to think about limits. What's my limitations? Well, first off, I have this sphere, and I needed to make it 5 more units. So let's take this as a calculator is concerned. And it's 22.43. So copy that, paste it, or just be not lazy, plus 0.5. Okay. So now this one has a 0.5 variation on it. So that tolerance, we have to establish that. Good. So at the barest minimum, I know I need this to be subtracted out. Sphere 0, 1. This one. Could I do that? No. Couldn't do that. Why? Because this has a hole. See it? So before I move this arm, object, apply, location. Okay, that way I can move it back. Control E, right click, R, E, right click, R, and then I'll merge those by removing doubles. And you can see that worked out quite well. Now I can. The model cannot have any holes in it, or Boolean will not work. Alright, so sphere 0, 1. Okay, there we go. We got our area. I won't delete that. I'll just get rid of it up here. This one's pretty easy. It's 10.5. So what's our limit? Well, we have a limit. When we raise our arm, it goes to, let's say, we'll use this line right here. Okay? And then our other limit is limited to right here, give or take. Now that's going to chop a lot of form out, huge amount of form, and that's only the limit based upon the up and down, not the in and up. So let's go like that, Shift D. What's our other limit? So right there would be our other limit. So what I need to do is make a form that goes all the way around all these limits. And I'll start that in the next video.